This is Module 2, Lesson 19, titled The Euclidean Algorithm as an Application of the Long Division Algorithm. The goal of this lesson: I can use Euclid's algorithm to find the greatest common factor on a set of numbers. As always, make sure that you guys take good notes throughout these videos. Pause the videos at any time and watch parts or the entire video as many times as necessary. Now, before we start here, once again we are having an algorithm. An algorithm is a repeated series of steps. This particular algorithm is named after a Greek mathematician named Euclid. It's very similar to the division algorithm, but this particular algorithm is used to find the greatest common factor. So this is actually a third way to find the greatest common factor of a set of numbers. Remember, you can list out the factors. You can use prime factorization that involves the factor tree and Venn diagram. But now I'm going to introduce a third way, and this only works for greatest common factor. Again, discovered by a guy by the name of Euclid. And in your opening, it lists the 4 steps of Euclid's algorithm. So what I would do is circle that, put a bracket around it, something so that you can go back to it if necessary. What we're going to do is we're going to use these steps to find the greatest common factor of 2 numbers. We're going to divide the bigger or the larger of the 2 numbers by the smaller one. If there is a remainder, we're going to divide it into the divisor. We're going to continue dividing that last divisor by the last remainder until the remainder is 0. And here's the thing that tricks kids. You might want to make an extra circle there. The final divisor is the greatest common factor of the original pair of numbers. Let's move ahead to example number 1. This picture here sort of describes how Euclid came up with this algorithm. Let's say that we have a room that measures 100 units by 60 units. We're going to fill it in with tiles, square tiles. We don't want any of the tiles to be cut. They got to be perfectly square. They got to fill up the entire space. They cannot overlap, and they cannot be off the edge. We want to know what is the size of the largest square that we can use. To figure this out, we're going to come up with the greatest common factor of the 2 dimensions, 100 and 60. We're going to use Euclid's algorithm to find the greatest common factor of those. So what we want to do is take the larger number and divide it by the smaller number. We are not dividing this completely. We may have a remainder. 60 goes into 100 one time, and when we subtract, we get 40. Now with Euclid's algorithm, we're going to take that remainder and we're going to put it as the new divisor. The old divisor becomes the new dividend, so that we're going to divide 60 by 40. That goes in there one time. We're going to subtract, and we get a remainder of 20. And I want to continue doing this until I get a remainder of 0. So I'm going to now put 20 as the new divisor. The old divisor is now the new dividend. 40 divided by 20, it goes in there twice. 2 times 20 is 40. And I get a remainder of 0. Now I'm finished with Euclid's algorithm. The greatest common factor of those 2 numbers is the last divisor. Remember, that was the one we circled on those steps before. 20. So what that tells us is the largest dimension, the largest square, can be 20 units by 20 units.